Hello. Let me know if you can hear me. How many have we got? 16. Hey, Cameron. Awesome. So I'm going to record this Blackboard session just for viewing quality. Either watch the recording or come join us in person. I'm cutting out. Oh. Thanks. Let me try this. Try eat it. Okay. Let me know if that's better or worse or the same. Okay. Now, why isn't this one working? HDMI. Do I have to change these at all? Because
Usually not, but sometimes it breaks.
oh, okay.
Is it plugged in?
Yeah. Oh no, it's not plugged in. That would actually help.
Yes, no.
Maybe.
If I switch it to internal.
Internal. This one.
Yeah, but it's not even showing.
Oh, sure. Oh. Yes, there we go. Thanks.
Lovely.
All right. Give it another couple of minutes. See if anyone else will join us in person. But for now, I will begin sharing my screen. Where are we going to go? Sample exam. Is there a stool? Is there like the stool that's normally in these, you know, the ones that are higher up? That would be great, thanks. Now, I'm going to try and line this so that I get a bit more. There you go. This is an absolute pain, but it's fine. Now it's like sit on it. All right. Are we rolling already? Mm-hmm. Oh, awesome. Okay. Cool. Well, hello everyone. We've got 20 people online and about less than 10 in person. I don't know what we need to do to make more people come in person. Does anyone have any? Free money. Free marks. We've already done that once this week. We need to do. We need something like the, you know, like the security movie nights where they have like the movie night and you get the free food after the lecture. That gets people coming to lectures. Anyway, hi everyone. Welcome to the exam revision live stream. if you've got any questions, stuff you want to talk about, put it in the chat. Today's a very relaxed session. I literally haven't prepared anything, mainly because I haven't had time, but we can talk about anything from kind of first principles to applications to coding and stuff that you want to go through. And we've got 2 hours. I haven't seen very many questions on the forum thread about like that people want to talk about. So I'm essentially I'm gonna start by just going through some just like general advice and kind of approach to the exam. I didn't get the chance to finish talking last week in the exam lecture because the Blackboard cut us off. So I want to finish that. So I'll go through this stuff, and then I'm going to tell you essentially what you need to study for the exam, and then we'll go through the sample exam. We'll try and get all the short answer done, and we'll do some of the programming. Some stuff is like in the last term's live stream, so I would just go I would watch that if you want the answers to the questions, because I would rather like essentially film some new content and try and build up a library of stuff rather than just like saying the same thing that I said last term. Yeah, I'm gonna try and keep the chat open. I really need to figure out how to do like multi-screens and stuff in person, but yeah. And obviously anyone in person, stick your hand up if you've got any questions. So I thought I might start it by talking about approaching the exam, because I know the exam has, in previous terms, has been difficult for some students, and so has a bit of a reputation as being a challenging part of the course. And you know, as a result, that sometimes people get stressed, and people get stressed about exams generally, and that's all fine. But I guess some just sort of context and advice. There's 2 types of hard problems, just generally. One is problems that are easy to understand and hard to solve, and you will come across those generally, you know, like in the labs, in any other course. Like I often think about algorithms problems like this, where it's like you know what the problem is, you understand it, like that, and then you have to figure out how to solve it, and that's difficult. There is a few labs I think in this term like that. And then the second type of problem is problems that are hard to understand, hard to know what the question's asking you to do, but once you understand what the question's asking you to do, it's actually very easy or straightforward to solve. And obviously this isn't sort of like a binary, there's, you know, mixes and matches of both. But I just want to kind of put you in that sort of frame of mind where sometimes the difficulty is just in understanding what the question is. And I'm probably getting a bit, going on a bit of a tangent, but like in any sort of industry, or just generally, the people who can solve these sorts of problems can get paid a lot. And then the people who can solve these sorts of problems get paid even more. Because sometimes just understanding what the question is, or even what questions to ask, is a really difficult skill. So like basically, this comes down to, you know, if you read an exam question, or some of you I know, you know, do the labs and you kind of read the lab for the first time and you're like, I don't get this. I don't get what the question's asking me to do. And that often is just like a combination of things. Sometimes it's, you know, the question maybe assumes something that you don't necessarily know or haven't remembered, or just was implicit and we probably should have put in there that wasn't. Sometimes questions are just badly written, and that happens a lot, especially when the domain is kind of complicated. And as I said, I've said multiple times about the project, we are now in the domain of, we're now in the complicated domain. Things aren't really simple anymore. And that means that, as I said here, exam questions are kind of hard to write, because if they're too simple, then they're too easy and everyone gets them, and that defeats the point of the exam. And then if they're too hard, then no one gets them, and that also defeats the point of the exam. We want essentially a bell curve of ability. So that's some context. What we really want to do in an exam, because like making you try to understand the problem is a bit painful, you know, when you're stressed, you just want to kind of churn and burn essentially when you're doing exam questions. So that's the aim, is to make the problems easier to understand, but hard or varying degrees of difficulty to solve. But sometimes if you might just come across a question in the exam that you're like, I don't fully understand what the question's asking me. And so my advice here is take a deep breath, just be calm, and know that once you know what the question's asking, you'll be able to figure it out. And that might take time. Reread the question, Sometimes reading the question aloud can help as well. And just, I guess, just generally try to go slow. And this is, I said this on the exam page, but there's this really cool quote from the, I think it's the Navy SEALs, but it's like this thing that slow is smooth and smooth is fast. And so if you go into everything just rushing it and not reading the question properly, not taking the time to understand what's going on before you dive in, because I know you just want to get coding, you just want to go straight into it. And that's completely natural because you're under time pressure. But taking the time to read the question, understand what's going on at the start, will help you in the long run. That's kind of just the theme of everything I've written here, so I won't go over it too much. It's the same thing with the short answer as well. It's interesting, people sort of, you know, when they've done this exam and then they talk about the programming questions being difficult, it's like, I didn't get the programming questions, blah, blah, blah. But actually, the questions that people do worse in when we come to market are the short answer. And it's usually because they rushed it, they didn't read the question, they didn't understand what was going on, or just they didn't know the concepts. And I don't like mean to sound a little belittling in that sense. I just mean that sometimes people, it's very clear when we mark their exams that they just haven't really understood or they haven't grasped the course concepts. And this is what I was saying in last week's lecture, is that you know, you've done the hard work already, and if you did the assignment, you did the project, you spent time working on patterns and good design, you will have the sort of foundations you need to do well on the exam. This is not an exam that you can just like study for the day before and then learn everything, you know, rote learn everything or whatever, and then do particularly well, because it's more embedded and deep than that. Now, you've still got a week, so you know you could get a lot of work done in a week and progress a lot. But to some extent, the work you've done or not done has sort of paid its reward already. So that's, yeah, that's a short answer. We'll go through some short answer questions today and just talk about writing responses and that sort of thing. The other thing is, you know, you've been doing a lot of writing in your blogging, the lab exercises, so that as well, you know, is sort of, we'll ask you similar sorts of questions to what you've been blogging about. We'll do the domain modeling question. My suspicion is that people are going to spend too long on this. Try and make it take 10 minutes, and people will try and do this sort of complete design and think of, oh, you know, what are all the possible methods I could need? It doesn't have to be that. It's an API. It's really simple. It's just an interface. You just probably need about 3 methods in each class. We'll do the sample one in a second. But don't spend too long on it, because I have a feeling that people are going to burn time on it and then not have enough time to do the programming. There's a few choice parts in the exam, which is designed to make you feel like you don't have to understand everything sort of, you know, 100%. If you're across 80% of everything, then that's okay. Now, there's a few, so in the short answer, there'll be kind of, you have to do probably 70%, I think, of the 70% of the short answer is sort of, you have to do these questions, and then the rest you get to pick 2 out of, I don't know, 6 or 7. And the other thing for the programming is for each, there's 2 main programming questions, and then the last part you can choose which one you want to do out of 2 in each question. What I would suggest is pick one at the beginning, just the one that is your gut feeling, I'm happiest to do this, this makes the most sense to me and I'm most comfortable with, and then stick with that, and don't kind of chop and change halfway through. Cool. I'll talk about this at the end. So let's do this at the end. I want to talk about some exam stuff, or some the sample exam now, because I feel like I've just been waffling for 15 minutes. So yeah, if you've got any questions, just chuck it in the chat. I will try and keep an eye on it as regularly as I can. Where are we? Okay, let's start. So, question 1, aggregation or composition, an online tool. Sorry, I'm just eating my words today. An online call contains breakout rooms. Any thoughts? I would do a poll, but I really am not having fun with Blackboard today. All right, for in-person people, who reckons it's aggregation? Who reckons it's composition? some people. Do we have solutions at lab 10? Yes. That's a great point. I'm very sorry. We meant to get those the theory question solutions out to you over the past couple of days, but I just have, you know, those weeks where just like everything happens all at once. That's been this week for me. So yeah, sorry about that. It'll come through in the next few days. You can learn how to answer. Yeah. I mean, I don't know. That's a good point about like how much should you write, and the answer is, I said this last time I think as well, where one student can write like 2 paragraphs and get 0 marks because they just waffled for 2 paragraphs and didn't answer the question. Another student can answer the question in a sentence and get 5 out of 5 because they hit on everything we were looking for. So in that sense, I know people are like, oh, you know, how much should I write and that sort of thing, but don't worry about how much you're writing. Just try to answer the question, and if you feel like you've hit on everything in the question, then that's fine. What we'll do, I'll try and give you an example with this as well as we go through the short answer here. So composition, sorry, I got distracted. Who thought it was composition here? Most people? Yeah, so I would say it's composition in that if you kill the online call, you kill the breakout rooms as well. I think that's a pretty universally agreed upon semantic. So let's write it up. I'll write a couple of these up. I won't write all of them up. Yeah.
So if you look at the lectures, if you look at the example application, they said, think of an example as lab contains compute, and they said that was aggregation. The keyword was contained in that, but that sentence had the word contained in it. So that's why I put it as aggregation. Could you explain a bit on that?
Yeah, for sure.
It makes sense if it's a composition, but then the keyword contained maybe makes you think it's aggregation.
I would say that like the contains like term and like semantic applies generally, in that like a car contains an engine, but there's an aggregation between car and engine. An online call contains breakout rooms. Really, you could say like any like field is a contains relationship in that sense. So yeah. So question 1. So say composition when the online call dies, so do the breakout rooms. That's it. I don't really think there's much else to say. You could make it a bit more verbose if you wanted to, but I would give this 2 out of 2. Cool. Next one. All right, software engineering practices followed in your project. Which of the following would you recommend against when completing the design and development of a similar software system? So, which of these may be considered bad practice? Planning an overview of the domain at the beginning, write the entire UML diagram without writing any code, do stuff in small iterations of development, wait until the prototype is perfect. No one in Agile uses object-oriented programming. The last one, the last one was just a joke, but all these people in the exam last term were like, I don't understand E. Is E the incorrect answer? So that's why I shouldn't put jokes in the exam. Any thoughts other than E? D? Yeah, I would agree with that. B and D, yeah. And there's this, entire notion of write the entire UML diagram before writing any code. Wait until the prototype is perfect. And those are sort of the giveaways in that they're the big design up front, where you get every single stage correct before you move on to the next one. Software just doesn't really work that way. There's too many unknown unknowns. There's too much going on, and things move really fast. So these are all good. I mean, this is what you did for milestone 1, right? Where you do your domain model at the beginning, or some of you did do it milestone 1, and probably some of you didn't, and then regretted it later on. Small cycles, iterations of development. This is like a really big thing that I saw for some groups in the project, where the ones that were successful got stuff merged into master early. And the ones that sort of fell apart, they did exactly what I said not to do in the lecture, where you get your project, you slice up the pie, and then you bring all the things back together on the last day, which is like how most group projects work in uni, where you have like a group report or something, but it doesn't work that way in software, and certainly doesn't in industry and the wider world. Cool. This is a very simple question, but let's go through it. So what would the above program print? So we make a new dog, we say that we've got an animal which is actually the dog. So its static type will be animal, and its dynamic type at runtime will be dog, and it'll print out animal.noise. Because the dynamic type of this variable is still a dog, it'll still have the same implementation, even though statically it's an animal. When it gets to it in real memory at the time, it'll print woof woof. No, won't make a noise because we've overridden the method. So we've actually just erased the existing functionality and returned something new. So if we said like super in the noise method, then that would sort of extend on it. But yeah, as we've said, we've overridden it. Yeah, not in this case. All right, so that's question 3. Question 4, what if you did animal dog equals new dog? What do people reckon? So instead of having, you essentially just move this to this line here. Be the same, dog.noise, yep. So again, it's like the static type of the variable is still animal, because that's what you said on the left-hand side, that's the static type. But then when it comes to actually running code at runtime, you will create a new dog. It'll be a dog that lives in the memory, and when we say dog.noise, it will point to, or sorry, animal.noise, it'll point to this method because it's actually a dog under the hood. Cool. All right, consider the following code. So we have a flight, and it's got a precondition and a postcondition. We've got a gold flight, which has a precondition and a postcondition as well. And we have these book methods. With reference to design by contract and the Liskov substitution principle, explain why the inheritance here is invalid. So if this is like, if you want your pro forma, because there's usually a question like this in the exam, stronger precondition, LSP fails, precondition. Some people think stronger preconditions, some people think weaker preconditions. When we say strengthen the precondition, I can get my whiteboard markers out for this one. When we say strengthening the precondition, you can think of your sort of function as like this funnel. So here's the inputs and then here's the outputs. And if you strengthen the precondition, you are making the funnel smaller. Because you are narrowing the subset in which valid input values are allowed. So in this case, before we said, well, you know, as long as you're, I guess, a real person, you know, age is greater than 0, name does not contain any spaces. But now we've said, actually, you now have to be older than 50. It's like if you buy a plane ticket and then rock up on the day, and they're like, oh, actually, you need to be older than 50 to go on this plane. You're like, well, I didn't sign up for that. I'll answer your question soon. So because we've strengthened the preconditions, you've broken the original contract. Because here we said, well, if you're greater than 0, then we're all good. Which means that if we made a gold flight, and we did what we did in the last question, where we said, well, flight equals new gold flight, we don't know what this type is at runtime. We'll do this here. And then if I say flight.book age is, I don't know, 45, and this is my ticket, then we'll think, well, this should be fine because it's an object of type flight, and these are the preconditions. But actually, we've changed that under the hood. And this is what happens when you weaken the preconditions. We break the Liskov substitution principle, because now the subtype, gold flight, is no longer substitutable for the base type. So if you wanted this as a 4 marker, I think this is a 4 marker. Yeah. 1. Preconditions have been weakened. 2. This breaks the Liskov substitution principle. Sorry. No, you can, sorry, yeah, sorry, strengthened, my bad. Yes, you've made the preconditions stronger, which decreases the the valid input size. So weaken means, well, actually, you know, you can come on this flight even if you don't have a valid ticket. So someone who does have a valid ticket can still fly. And the same thing is true in reverse for the post conditions. So this breaks LSP. Now, here's the interesting one. I think in the actual, I think I changed this slightly because in the old one you had to give an example, so that was why it was 4 marks. This would probably be only 3, in that the third mark here is this causes the behavior when. Sorry, I wouldn't expect you to get this just by reading the question, just because I think I changed the wording of it from last term. But essentially, this causes the behavior when age is less than or between 0 and 50 to be undefined. And this is the idea of design by contract, right? If you don't meet the preconditions, then all bets are off. The behavior is undefined, which means that if you do something, if you break LSP, behavior that you think is defined is no longer defined, which is problematic. So I would probably give this, I don't know, those are 2 marks there. This would probably ask for an example as well. Okay. So for short answers, 5 questions are different with 10 questions. Is there a recommended time, like time for 5? I don't quite understand the distinction you're making between 5 and 10 questions, Minshin, but yeah, if you want to elaborate on that, then I can answer to it. In terms of like time, some questions will take longer, some questions will take less time. Some of them will, like some stuff we have a better understanding of. There's no sort of hard and fast. Like you have more than 1 minute per mark if you're doing, you know, that whole thing, because there's 100 marks and 180 minutes. So yeah, it'll be completable in 3 hours. I'll talk about that more at the end though. So could you give an example for the flight where the precondition is weakened? Yeah, sure. Like if you could say precondition, copy this. So we're going to make a new class, silver flight, extends flight, and then say, you know, public void book. And now we just take this out. So you've weakened the preconditions, which means that now more people can come and call this method that couldn't before. But that's okay because all the people, I say people, you know, they're semantically clients who could use the method before can still use it. The behavior's all the same. Nothing's changed. Age can be -2. That, yeah, sure. Cool. So that's all the LSP stuff. I would think about what happens with the reverse, with the post conditions, because the same is true in reverse, except now the onus is on the system, where it's like the whole funnel thing. You can strengthen the post conditions, right? You can't strengthen the preconditions, but you can strengthen the post conditions. You say the function will do more, or if you weaken the post conditions, you know, saying, well, the function will do less. That's like, you know, like I paid for a flight and I paid for a meal on the flight, but then they didn't give me the meal. Sorry, I don't have a whiteboard marker, eraser. Is there erasers in here? Never mind. Okay. Thank you. All right, question 5, code smells. This is probably one of the most useful parts of the course, I think. It's just being able to look at code and go, there's some problems here, but not just to be able to identify that there's, you know, poor design at play, but also figure out what's at the root of it. So for this one, I think I copied this from a group that did the project last year. I wrote this question on the fly just for this sample exam. But any thoughts on it so far? Like there's quite a lot of code to look at, but hopefully, like, because the domain's familiar to you, you can just kind of go, oh, yep, this is kind of like our project code that we wrote, and start to think, well, maybe here's some places where the design could be better. Repeated code identity, yeah. Repetition, DRY. A few string things you could be used, yeah. I would say that's probably the main thing. Like you essentially have the same function written a bunch of times. Too imperative. The fact that it's written with like for loops and stuff, I don't know. It depends what if your methodology is. It's really funny. We introduced streams into the course last term, and everyone's immediately hooked on them because they're fantastic. And I love streams as well. But like there is, I mean, it's fine to program in normal for loops and stuff as well. So I wouldn't call that a smell as such, but you know, if your like style was, oh, we have to use streams, then sure, that's something to pick up on. Does four place bomb does the top if statement do anything? Yeah, I mean, that's a great question. You just have like a whole benign chunk here. I don't know. What about this one here? I reckon this bit of code is kind of interesting. It's hard to tell without seeing broader context. But yeah, let's read Cameron's question because it's kind of related. We were told to not use instance of as much as possible. I don't know who said that, because I don't think I did. I don't know, maybe Ashesh did. But I think I said this on the forum when we did the assignment. Like, there's nothing wrong with instance of. There's nothing wrong with there's nothing wrong with switch statements. There's nothing wrong with normal for loops. It's like all of these things are fine as programming constructs. Like instance of wouldn't exist if it was just objectively bad design. But it can be misused, and I think I've still got it on here, by the way, of like this one. Yeah, the type checking. If you're doing all this type checking, instance of, then that's a smell. The pattern, right, or the anti-pattern in this case, is where you start to see this thing where it's like, maybe I can do something here to make it better design. In this case, you can just use polymorphism, chuck it in a method that belongs to the class itself, and you avoid all this type checking stuff and let what we looked at in question 3 handle it all for you. But I'm not sure how to use breakout, not instance of, when looping through entities. Even in the project, the only way I can see is move multiple lists. That's a good question. What I would, my advice for that would be, like, you have a method that's like public. I said this to a couple of groups. You have something like this: public list entity. Maybe not entity. This is hard. You might have to use generics here. It's like public T, list T, entities, or get entities of type. And then what you do is you take in, sorry, let me actually write this in Java because the generic stuff is a bit wild. Get entities of type, and you take in a class. Here we go, a class of type T, CLZ. And then what you have is like return entities.stream.filter e.getClass.equals CLZ. So that's kind of gobbledygook, but let me just go. Cool. What are we doing here? Cannot convert from stream entity. I think we need to do this thing where it's like T. There we go. Nope, that doesn't work. I saw this stuff the other day. Can you do that? No, okay, so we need to do a filter, and then I think we need to do a map after that. Dot map e te. Can we do that? This is really interesting when you start to play around with like types and generics. Collect. Okay, so this is the first problem. I don't think this is going to work. Yeah, very complicated. This is why you don't try to do this stuff on the fly. There's a way to do it. I would play around with it, and the essential idea is you can parameterize the type using this like object of type class. And a place you might have seen that before, just if you're like, what's this class stuff, is in the not here. I don't know if I have it in this one. You know the function like assert throws. So that takes in an object of type class, which is what kind of exception you want to throw. It's when you say like, you know, illegal argument exception dot class, and then the actual executable to run. But this is just essentially a type. So you can play around with that and say, well, I want all the objects of a certain type in this list. And that way you don't have to play around, because then you're not dealing with instance of as like code rather than data, if that makes sense. And so you can just pass it in as a parameter. I'm sorry I couldn't do it on the spot. It's some complicated thing. So the generics get weird sometimes, but I would have a think about that. Yeah, so you want to avoid using multiple lists, that's a code smell. You want to avoid having these multiple methods, that's a code smell. And, well, I can tell you now, not on the exam. Because if I can't do it now, it's not going to be an exam because the exam's already written. So, where are we? Yeah, you can essentially solve most of this stuff with one of those sorts of methods. This one is probably just more generally like the fact that you are doing this like instance of and then immediately typecast it, and that's the purpose of the entire method, is like, why are we passing in an item in the first place? Maybe you could just pass in a bomb and do the typecasting somewhere else, or maybe no typecasting at all. It's really hard to tell without the sort of broader picture of where it sits in the code. But this question is just asking you, what are the smells? If you know, how would you resolve them? If you can understand them, what are the underlying design problems? And a lot of the time, you just don't have enough information to tell. Okay, what about this one? I think I took this out of a student's assignment from this term, because I think everyone, at least that I saw, had this problem. Too many dots? Yeah. Does anyone know what the name of the smell is? I wouldn't even say, like maybe, I guess this is maybe like law of Demeter. Law of Demeter. This law of Demeter isn't a smell. There's a particular smell that probably talks to the law of, like speaks to the law of Demeter. Yeah, feature envy. Louis got it. And as a result, so it's like these are all correct in the sense that feature envy is the smell, and then the problem is it doesn't abide by the law of Demeter, or it has too much coupling. So it's also important to be able to differentiate between what is the sort of, you know, the symptoms of the problem, right? And what's the actual cause of the problem. It's like the whole fruit of the poison tree thing. So in this case, it's like, you know, you've got file transfer, get file name, and then you do all this. The construction of the response object especially, every term in the assignment, it's the same thing where, you know, file transfer this, file transfer blah, blah, blah. And you're like, well, if you're talking to the file transfer so much, we might as well just give all this functionality to the file transfer and have it do it itself. So as a way to solve this, you'd have something that's like toEntity response, which returns an entity response object, just like the toJSON. Cool. Without any questions, we'll keep going. 3:40, so I reckon we can get through most of this pretty quickly and then do coding for the second hour. So question 6. Any thoughts? What pattern could be used here? We've got some milestone 4, new requirements. You have to do some new entities. We've got 4 different types of entities, and each of these new entities can be produced as a creature of either fire, water, earth, or air. How would you model this? Now, sometimes if you're just like, I don't know, I have no clue what this could be, list out all the design patterns and cross out the ones that it won't be. Abstract factory, yep, that's an option. Anyone else want to take a stab out there? The one with this one where it's like, yeah, it could be decorator, strategy. The one with this that kind of gives it away is we don't actually, like there's no functionality, right? There's just saying there are new types of entities and these entities can be produced. But we don't say there's, you know, sort of, these are what the entities can do, or this is how they behave, or we can add this functionality. It's just creating it itself. So that is kind of a bit of a giveaway that you have creational design patterns. Question asks, oh, I gave it away, sorry. Some questions will say like, I don't know, some questions might go, we want a creational design pattern, some just might say any design pattern. So yeah, I reckon abstract factory is the best way to go here. And I'll go back to the slides because abstract factory one of those wild patterns that, honestly, I could probably understand a bit better. So it's like the chair thing where you can have 3 different types of chairs. You can have chair, sofa, coffee table, or just like furniture. And then you have 3 sort of different styles of each. And then as a result, you can have these different types of factories, and then each different factory produces a different object. So you have chairs, you have coffee tables, and then the interface will say, I'm going to return these different types, and then the implementations will say, here's my Victorian type, here's my modern type. And you can apply the same thing here where you have, you've got possessor birds, cockroaches, gnomes, and phoenixes, and then you'd have like a fire, water, earth, air subclass. Let me draw this on the board. One's like create Phoenix or whatever. And then all the subclasses implement that. Yeah, I know. That's why we're recording it. But I wish there were better camera setups for the lectures, but I'll try and like move the computer so you can see if that works. Doesn't really work. No, it doesn't work. Don't worry, you didn't miss much. So yeah, that's question 6. Question 7. And now we get into the choice parts where you can pick 2. And it doesn't have to be any particular 2. That's a great question. Like what that is trying to say is each design pattern will have key characteristics, and I'll probably go through what each of the key characteristics are at the end, just some kind of off the top of my head, sort of things to think about, things to look for in a scenario where it's like, what's the design pattern? And you'll be able to see those mappings, and when you implement the pattern, you'll need to create those mappings as well. So for example, the state pattern, you have a series of states, you have actions and transitions, and the actions are common across each state, but the implementation is different. That's one example. So each sort of pattern has its own things about it, characteristics and kind of terms as well, like hooks in the template pattern that you kind of go, okay, I can sort of think about this when I'm implementing it. Okay, a user bought an application that reads in data in a JSON format, displays the results on a web page, but later they realized one of their data sources is in XML. The user doesn't have access to the source code, so they can't actually change the application. What design pattern could we use? And again, we're doing this characteristics mapping. Adapter, visitor, maybe visitor. I honestly think both are correct here. Yeah, because you could, so the argument for adapter is, now I feel guilty about drawing. Adapter is non-examinable. Yeah, like, so you could say visitor. I would say visitor. The reason I would say visitor is that, like, both are sort of based around the principle that your code is open for extension and closed for modification, in the sense that you can just add something on top. Like an adapter, like, when you get a you have like a power board, and then you want to like go from like the UK or the UK PowerPoints to the Australian PowerPoints, like your phone charger or whatever. You plug in an adapter, and it's like, oh, you can if you want. Like, there's nothing stopping you. We just won't design a question that the only answer could be adapter. And like, if you didn't, like, it's the idea, if you didn't know adapter, you'd still be fine. But you can use it if you want. Sorry. Yeah, so like a power adapter is where you plug it into the port, and then it's like something that you plug in rather than you go in and change stuff. And the visitor is the same idea, where you can kind of build these. That's a great question. I'm gonna use my OneNote. Just give me 1 second. I'm gonna draw stuff so that people in the live stream can see it. Yeah.
Like, won't you still need access to the source code if you want to use visitor pattern, like for the exact method?
Yeah, that's a good point. And in that case, probably adapter is it's one of those questions where it's like, what do you mean by that? Because that has so many kind of impossible implications that that you could still. I think probably adapter is probably the answer. The I didn't write that question, but there's probably the original intention where it's like you can just have this system, to talk about what I was explaining before. You have this system, and then you just kind of plug on this adapter like that, and you don't actually have to. Well, I should rather say you have this adapter which takes in the output of this system and then converts it to something that is usable. So in this case, like it converts it from XML to JSON or whatever it was saying. The reason visitor I think is also like valid is that you could build in a hook, which is like your accept method. These are some bad drawings of hooks, and then what the visitors can do is kind of latch onto the hooks and provide some form of external behavior that allows you to kind of interact with the internal mechanisms of the system. But as you pointed out, that requires actually being able to build the hook. So if you didn't have access to the source code, then that's kind of hard. So the key idea though, like I would say, I would mark either as correct. You are extending functionality without having to go in and change stuff. Now, from a design point of view, I actually don't think that's particularly great, where like open for extension, closed for modification doesn't necessarily mean you just build around stuff, because what happens with that is then you start building all these. I said this in my tube the other week. You start building all these abstractions of abstractions, and then you're left with this kind of. It's like the whole incremental design problem, where everything just kind of is piled on top of one another, and you don't have this nice kind of coherent design that works throughout. Don't you still need to add a method inside of the? Yeah. Sorry, I think I read that before. Cool. That's question 7. Again, lots of these questions are really sort of up for debate. And when we mark the exam, we often have discussions about we'll have one answer in mind, and then people like students will come up with another answer that's also a valid interpretation. So I guess just sort of take that as a don't feel like if you completely get the wrong pattern, then you're not screwed or anything. If multiple people and people want help sessions, then we can do that. Just chuck a post on the forum and heart react it if you want more help sessions. This is the sort of the last big thing, but yeah, if you want to just chat through stuff, then we can get some tutors around for that. So this next question is about concurrency or asynchronous design. And it says UNSW has asked you to build a web-based system where residential students can select rooms for a new year. The problem is when the system's built and deployed, as soon as the system's activated, the residents will be going straight away because they want the best views, the highest floors. So that might result in 2 people trying to access the same piece of data at the same time, causing data corruption, logic errors, essentially a race condition. So you've got to build, you're just building an API, you're building a web server. How would you design it to avoid this issue? Yeah, synchronization essentially. We deal with the problem of concurrency by not doing concurrency. We don't parallelize the processing of web requests. So what I mean by that is like you've got an API here, right? This is our poor little API, and then hundreds of students are going to bombard it with requests like /room/select, and then we have like 100 of these all happening at once, and they're all coming in, and they hit your web server. If you think of like your Flask server in 1531, there you go. And you've got one endpoint, which is this room select thing here. So how do we handle all this stuff happening? Because then you've got, this is your API endpoint, and then this is your actual system here, which has maybe like a database or something, and there's some interactions here. the point being, there'll be some processing of logic, and if that's done at the same time by two processes, you're mutating the same piece of data, you get race conditions. So there's a bunch of things you could do. I would say the best design, if you're trying to optimize stuff, is you put some sort of synchronization or a lock. We don't really talk about locks, but we'll just think of it as being synchronized. Put a lock around this stuff. Put a lock around the stuff that is going to cause the problem, because you want to sort of minimize your surface area of what do you call it? You want to minimize the surface area at which you are synchronizing. And if you did lab 8 and the concurrency question at the end of that, you would have understood that you want to minimize, because otherwise there's no point in running it in parallel in the first place. In this case, it's a bit different. Like, you would be okay just essentially synchronizing the whole web server, where you only deal with one web request at a time. Like, it might be a bit slower for people. They're waiting a few seconds before the thing returns, depending on the load. But it doesn't really matter. And like, a lot of this stuff's kind of out of scope in the sense that you just want to think about, well, there's a piece of shared data, more than one process could update it, which means we have a race condition. How can we solve that? Well, the singleton pattern allows us to do that. And that might be actually making this class a singleton, or it might just be doing a little synchronized in the code, or it might be just synchronizing the entire web server. How specific? Yeah. Would you describe? Yeah, I think I just answered that. Okay. And probably the other key idea to this one, sorry, I'll just answer your thing in a sec, is you want to synchronize it such that these are processed in a queue, and that if two people come in at the same time, one is selected and processed, and then the other is selected and then processed. Sorry.
Sorry, is that okay if we say, like, we can design this as a singleton pattern? Let's set place as we design this as singleton, without saying synchronized.
Yeah, I would, no, because the singleton pattern doesn't always, like, it usually does mean synchronization, but not, like, actually, that's not true. You can have singletons without synchronization. A singleton just means there's only one of them. And what we often do is, like, you have this, like, the bank account example from the tubes, where it's like, only one person can access the bank account at a time. So what we'll do is we'll have this object that there can only be one of. And you do that using, like, the whole private static thing, and you'll get instance method, where you can only, so sorry, here's the bank account access, and then here's the bank account. And then you can only ever have one of these. And the methods are all synchronized, which means that you can only ever have this interaction happen one at a time. But you can also just have the singleton where it's like, I actually only want one of these classes to exist. I see a lot of code at work that's just like, you can have this thing in Java. I don't really know much about it, but you can do this thing where it's like @singleton. And that doesn't necessarily have to have synchronization as such. I think most of the time you probably would do. The short answer is I don't know, and we wouldn't give you a question that's like singleton without synchronization or vice versa. Like, they go hand in hand, but probably, like, for this question, I would say that you need the word synchronization in your response, or locks, I guess. And you need sort of reference this idea that the requests are processed in a queue, or certain things are processed in a queue because of the fact that you're synchronizing it. Does that make sense? Yeah. All right. This one's interesting, I think. So, firstly, what's the problem with encapsulation that's going on here? Come on. Yeah, protected. Protected fields are a smell. They're just usually bad practice, because often you will want to encapsulate data even from the subclasses. You won't want the subclasses to be able to go and modify the value in the superclass, whether that's because of LSP maybe, or just coupling as well between the parent and the child classes. So we usually just make it private. There's certain exceptions like static and finals and stuff are fine. Methods are okay to be protected as well. but yeah, in this case, that's the problem. Now this one's interesting because this idea of like covariance and contravariance, which is also basically just like the Liskov substitution principle again. But if you take this, the easiest way for some of these questions is just to take the code and put it in a Java file and see if it works, and try run it, rather than just trying to like reason about the code without, without actually seeing what's going on. If I just do this. Now we have this problem here. This method must return, that's fine. But now we have this problem here of, what do we have? Yeah, here we go. The return type is incompatible with ae.foo string. What's happening here is you're saying, okay, I'm going to return an array list in the superclass. But then in a subclass, you override that and say, actually, I'm going to return a list. And based on what we just talked about with the LSP and design by contract, can anyone see why this is problematic when you're talking about these like types in particular? Before we were talking about just, sort of preconditions and postconditions, which weren't actual code, but now we're actually getting into the types themselves, and Java picks up on this for us. Array list is an implementation of the list interface. Yep, that's right. So list extends array list. Yeah, essentially you're weakening the post conditions because you're now returning a super type of the original return value. If it returned a linked list in B, it wouldn't be substitutable for class A. Yeah, spot on. So the superclass says, I'm going to return an array list. This is what you get. So you could do, again, polymorphism, declare an A, but it's actually of type B. And then say, okay, well now I want to invoke this, this foo method, but you could return a linked list, which violates the original post conditions of the foo method in the superclass. So again, it's all the same thing. You're breaking LSP. The only difference is that Java picks up on this for you because it's all like at a type level rather than just like a sort of semantic, this is what our function does with the WOFC level. All right. It's 4 o'clock. I reckon let's take a short break. This one I explained in the last lecture, live stream, but essentially this is the entire problem with Java effects and a lot of like these UI frameworks where it's like if you've ever done Swift or any sort of iOS development where you have the like drag and drop between, essentially you get like a UI. Oh, sorry. You get a UI. And you can like edit the UI and stuff, and it's a nice sort of little thing where you can drag and drop elements onto, kind of like Figma, except it's actually the actual implementation. And then you have your backend, and obviously you need a way to link your view to your model or your controller. And so you have these links, but the problem is essentially the controller doesn't work very well as an abstraction. So you have like data in here that is coupled to data out on the UI, which is coupling basically. Previous question, no, yeah, it wouldn't compile. Sorry, to go to this one here. So the code would not compile as the inheritance breaks covariance. So contravariance is when the parameters, I can't remember it off the top of my head, but it's in the lecture slides. It's again inverse for, it's the same thing. There's a whole preconditions, postconditions thing just wrapped up in parameters and return types instead of just like Javadoc. So covariance is the return type and contravariance is about the parameters. And they work in an inverse way, same as preconditions and postconditions. So yeah, let's take a break, get some water, go to the bathroom, get a cup of tea, and we'll be back at 4:10 to talk through. We're gonna do question, which one? Not this one. Question 14, and just talk about that. So thank you, and I'll see you soon. Hello, and welcome back. And my internet's crap again. Okay. Cool. So, sorry, we're in a bit over time. Let's do this. So, question 14. This was a question in the exam last, back in T3. And this is what I kind of refer to in the sense that, like, some questions are just hard to understand, and people found this question hard to understand. To be honest, probably not that well written of a question. And the aim for this term for the exam, I've got a tutor sitting in it at the moment, actually. So if they finish it in time, I will tell you how they found it. But the aim is to make it sort of, again, easy to understand and, you know, easy to challenging to solve, and to kind of give places where it's like the labs, where you start out with, you know, something simple and then something a bit more complicated and then a bit more complicated, and you know, you kind of progressively work your way up, just like, you know, most educational stuff that's put into tiers. So we have this thing that's called Wastebook. Students have to make a little social media platform. Each member has an ID. Each member can be added to the network. They can follow other people. They can't follow themselves. Two people are friends if they're following each other, and then the popularity of a user is how many people are following them. So we're given some code inside Q14. Let me just, oh, sorry, we need to do the domain modeling as well. We'll do that next. Okay, get rid of this. So here is, where are we? Question 14. Okay, so here's the controller. And we also have a bit of generics going on here where P just has to be comparable to other objects of type P. So we've got some people, and we can add someone to the network. Okay, all right, we've got this follow method. Now immediately, hopefully, this stands out to you as problematic. Yes, I am sharing screen. This immediately stands out to you as problematic because we have lots of nesting going on. Again, this is the code smelt. What's the underlying design problem? Not sure. Okay, let's just keep looking. Then we have this get popularity method. Yeah, okay, well, interesting. VS Code's doing the highlighting thing for me where I have the same line twice, again. Maybe some repetition going on there. And then we have this whole popularity thing. Maybe we could make this a bit more concise. All right. Oh, and we've got this iterator. Oh, yeah, sure. Yeah, we've got an iterator where we can compare different, or have different ways of comparing, and then we create the iterator and return it. All right, and then we'll do this in part D. So that's the first class. All right, let's have a look inside person. What immediately stands out to people here about this class? Anyone? You think there's kind of a lot of stuff going on in this one, and then there's really nothing going on here. Yeah, there's no logic other than getters and setters. So that's the first, probably the main problem, and that's the main thing we're going to do when we refactor is get rid of it. The other thing is, and not many people picked up on this, but I would pay attention to the fact that we've got the two lists here, and think about, you know, if we go back to the spec, if you're following someone, you are classified as friends if people are following each other. Rather than having this sort of duplication here where you have following and friends, maybe we can just have friends as like this captured value. Again, sometimes you might want to actually store it for performance reasons, but in this case, we don't really care. That's another thing. Probably another smell. I think one person pointed this out, or at least one I marked this, is that like there's not really much point in having a generic type here as the ID. We kind of say it in the question where it can be of any comparable type, but realistically, it's probably just a string to have some sort of, you know, like UUID or something that's generated. So, okay, let's do this. Let's do some refactoring. We'll start with this list here. This is fine. Now, again, number1.getID.equals. Immediately, you can kind of see the law of delimiter being broken here, where we've got this whole, getting equals, and we loop through this variable. We can want to delegate as much of this stuff as we can to probably the person class. So what I want to say is really just person1.follow person2. And then let's just kind of copy this. Oops, sorry. And then we're going to have a method public void flow person p person. Okay. Now we have all these people. Interesting. We kind of don't really need this outer for loop because we were just doing a bunch of checking there. Oh, we need to actually check the person. That would, because at the moment this is just a ID and not the actual thing itself. So let's do something like we'll just say public what's it called? Person. Get person. I'm going to take in the ID and return people dot string answer. Taking a bracket which is the p dot get ID equals ID. Then we want to filter. We want to find first, and then you can assume ID is always valid, so this will always is optional. Will always be able to be unwrapped. So then we'll say person p1 equals get person. Get person, and just invoke for method. So let's go back to defining it. We can kind of get rid of all this sort of checking stuff. And this is another one here where it's you're inside the following class and morphing breaking English. So rather than that, we can do it ourselves. Say dot add member2. Sorry, person. And then now this friend stuff here, again, we can calculate the friends based on the following. So we're just going to get rid of this and delete all the rest of this code. And in fact, maybe that's all we need. So, oh, we have this method add friend as well, which I don't think does anything. Oh no, sorry. We used to do something before, but now it doesn't do anything, so we'll get rid of it. Now, when we get friends, let's say, how do we do this? Maybe we do need the friends list. Sorry, I might have misthought here because you need to know. Oh, I know what's going on. So we'll say we will have our friends list actually. For all following check is following this. Yeah. I guess, I mean, you could do it at the, you could actually just take the functionality out of person and do it at the control level, which now that I'm thinking is probably a better option. Follow is undefined for the type P. That's weird. Yeah, so what I reckon you could do is you get given a person and then you loop through all the other people and find who both they are following and is following them. I thought that following being friends are two different things unless there is a rule that both people follow each other, they're friends. Yes, I think that's what it says in the question. Yeah, if two people are following each other, they're classified as friends. So what we might do is actually just get rid of all the friends functionality here. And again, I kind of do this on the fly to give you an idea of like what your thought process might be in the exam, where you kind of just got to like try stuff and figure it out and go, oh, well, these are the actual sort of semantics of the problem. So what we'll do is say person, or go, how do we do this? We'll start by getting the person. P or person. And then what we'll do is say for, actually we'll return people.stream. You could do this just using normal code, by the way. I just like using streams. People.stream.filter. And then we want to say, well, is A following B and is B following A? So P dot is following, sorry, we need other. P dot is following other, and other dot is following P. And then we're going to reduce, which we're just going to do it using, we're just going to count up the, actually no, we don't even do that. We can just say dot dot size. No, we can't do that. Okay, let's just do collect and dot size. And type safety, references to the generic type P should not be parameterized. Yeah, this is, oh, I should just say P here. Okay, there we go. Cool, and that's it. And we actually just cut out all the friends functionality out of here, which is pretty good. This is still kind of a data class, but that's mainly because there's not a whole lot going on in the problem. And I think that's kind of all our refactoring. Or maybe not. This one here is a bit interesting. Because again, we're doing this thing where we get the following and then check following.contains. So we're going inside and reaching and finding the array list. So let's go through all the other in people, sure. This one we can actually probably do a reduce. Let's go. So return people.string. Dot filter. So we just want, what is it? Popularity is how many other users are following them. So I want to say other, and say other.following, or is following person. Yep. Then, oh, we don't even need to do a reduce. I'm talking nonsense. We can just say dot collect. There's probably a nicer way to do this, but if in doubt, just turn it into a list. Dot size. Okay. The method is following is not applicable for the arguments P. Oh, I know what's wrong. Get person. Okay, and then we can get rid of all this stuff here. You could do all this with just for loops, but we can do it using streams as well. Now, this one here, what's going on? Follow is undefined if the type P. Public void follow person P person. That's interesting. The method follow is undefined for the type P. Am I missing something? It is void. Oh. Pass in P2. Oh, sure. Sorry. P1.followed P2. Again, this is like, why are we using generics here in the first place? Really? If you refactored, you couldn't refactor it to remove the generics in this case, just because that's like part of it, as with any refactoring question, is keeping the regression test passing. So by the way, if we just run these again, they should all still pass. Hopefully they do. And yep, tick. Happy days. All right, so that's parts A and B. You got half an hour. Now we're going to do this iterating, updating. I think I have an older version of VS Code or something. I don't know. I just haven't updated it, and I quite like this little thing where you get the report and you can see like how it went, and if it fails, it gives you the full stack trace. Yeah, I don't know. So again, this is one of a bit sort of harder to grasp, and we wouldn't ask you a question that's sort of this kind of abstract, or like a lot of people just saw this and went, what? I don't really get it, which that just kind of happens. But we want to try and avoid that. So at the moment, there's a iterator, which at the moment does nothing. Like this, it literally does nothing. It's just a wrapper around an iterator. It's a benign abstraction. The iterator can be created, so you can either order it by popularity or you can order it by its friends. Now here's the thing. When a new member is added to the network, the iterator is invalidated. Hopefully you're familiar with that concept where you've modified the thing you're iterating over, so the iterator does not remain up to date. Okay, what if we could use a design pattern so that when we update the original object, the iterator gets notified and changes accordingly? But we have to actually store the network members inside the iterator. So we want to modify the next method so that it still has the highest rank according to the given comparison method, which has not already been traversed, and then remains up to date with new members being added and any connections made. What pattern could we use here? I've kind of used a few buzzwords that might indicate a particular pattern. Yeah, observer. I mean, like updating, it's literally in the question name. And so here's an example. We've got Romeo, Hamish, and Evelyn. So we start out with Evelyn, then Hamish, then we add Darcy to the network, and then Romeo is next. So this is currently at the moment, but we want to say Darcy has popularity 4, and so they kind of slot next in the, jump the queue essentially, and then we want to get Darcy and then Romeo last. So let's start by saying, well, all right, I need my list of list P or list person P members. And then when we create the iterator, we'll pass in our members. Okay. Oh no, hang on, sorry, I've written the constructor twice. So we'll also want the members. Cool, so we've got the iterator to wrap around and then our members. And now we need to go, well, when we add someone to the network, oh, sorry, people. Nope. We need to make a copy of this, so I'm just going to go new array list person. And again, we're making a copy here because like we can't just give it a pointer or a reference because that would actually update in real time, whereas we want to implement the notification manually. People. Cool. So now, when we add person to network, we need to do the updating, or I should say, broadcast notification. And we're going to do that by saying, well, how will we do this? Well, we almost need a list of iterators. So we'll say iterator person, no, it's iterator network. P extends comparable, sure. Okay. So a list of iterators to P. And these are like your subscribers. array list person P. Sorry, iterator. Okay. And then what we need to do is say, well, iterators dot for each I dot update. And then what we'll just do is pass in people, or say pass in a copy of people. Sorry. Now, the update method doesn't exist yet, so let's write that. Say public void update. That takes in our new list. And literally all we need to do, well, all we need to do to start with is go our new members equals members dot, sorry, this dot members equals updated people. And that's the first problem of, okay, now we've updated with the new information, but we need to actually be able to preserve where we were before. And not only do we need to do that, we need to say, well, we've already passed through these two, right? We've done, yeah, Emlyn, then Hamish, but then we need to say, okay, well, Darcy's been added to the network, and we need to process Darcy next and everyone else who wasn't already processed. How might we do that? Any rough thoughts or designs? This is kind of tricky. There's quite a few ways you could do it. Probably the simplest way, I don't know how great the design is, but let's just say private int current index. And what we need to do is say, well, whenever we go next, we'll just go current index plus plus. So we keep track of where we're up to as we progress along the iterator. And then what we'll do is just say, well, okay, iter equals, how do we do this? No, sorry, ignore that. We're gonna do it differently. We need to change the ordering. So if we go back to here where we actually create the iterator to begin with, we do this whole, you know, sorted and then map and then collect and then get the iterator. Sorry, I lost my train of thought. Maybe we actually want to pass in a new iterator. Oh, sorry, I've forgotten how to do this question. Essentially, we could do the index thing. Let's do the index thing. That's the wrong one. Okay, so increment the current index, and then how do we do this? Maybe you can index count call next. Maybe use the index count call next several times. Sorry, I'm drawing a mind blank. I thought I could do this, but I've honestly forgotten. Essentially, you want to update the problem I'm having at the moment is how do we change this iterator so that you can how do we reconfigure this iterator so that we went through all the values we went through before, but now the ordering is new. And yeah, sorry, I really should have just looked at the solutions before trying to do this. But I'm conscious of time. So essentially, the main idea is that it's an observer pattern and you have this updating. The mechanics are a bit annoying. And we won't give you a question this sort of, like, we won't give you a question this hard in the exam, essentially. But I will find the solution to this and put it up, and I'm very sorry that I couldn't do it on the spot. Let's crack on. So this one, I'm just going to talk about, because again, we're short on time. Switching comparison method, this is just a strategy pattern. And if you take in an iterator and you essentially do this thing again here, but you create a new comparator. So I'm not going to go through it. Lesson Java. Oh, Java's easy. This is just like hard design. And again, it's like when you're in an exam or trying to do it in front of however many people here. Edit generics are hard. Yeah, generics are hard too. Yeah, it's just like try and keep it cool. It's the main thing. So this is again strings, not strings. Copying code, not great, but again for the sake of time. So this seems fine. And then we're kind of going to do the same thing as we did, which return the iterator, but we also need to go through already all the people that we iterated through previously. So that again, it's like when you iterate by popularity before, and then now it's by friends, and we just pick up from where we left off. Yep, I'll put the solutions up to these later. I feel like me sort of bumbling around trying to remember how to do this is not that helpful. So that's the rough design though. And again, like the idea with the exam is that if you understand the design, you'll be able to do it. And you won't get kind of caught up in really ugly stuff unless it's sort of specifically like the thing. Some questions I kind of think about in a similar way to Lab 8, where some of them are just kind of hard to. You're like, it's again easy to understand but hard to solve. Like the where one. This one's just kind of tricky because you have to do this weird caching thing, and then there's like, how do I go through the iterator without using stuff up? And it's a really interesting problem, I think. And we wouldn't give you something quite like this in the exam, but a similar idea where it's like, I know what I need to do, but how to do it is actually quite challenging. Yeah. Okay. Do you have tips for understanding difficult questions and or where to focus if you can't fix a bug, get generics working? What is the percentage test score? Basically, for the tests, we'll give you one basic test to each question in most instances, and I would say 100% of the test scores are from hidden tests, but you might, like one of the hidden tests might be pretty much the same as the example test. So it's like you don't have 100%, you don't have assurance that, it's not like the project where we ran it all before you and you like, here's your score, this is your submission, and you just got to be confident in your solution and write some tests. They don't have to be super extensive though, and we're not marking the tests. Yeah, try not to stress. Honestly, like this again, not a very well written question. Not this one, sorry. This like whole friends question, not super well written. And sometimes just like thinking about these problems is difficult. I honestly wish I prepared more for this today's thing, but I've just been very busy. So I want to go through the domain modeling one, just to kind of illustrate that it should be fast and quick, and it shouldn't be, spending a whole lot of time on it. But do I have any quick tips for understanding difficult questions? Like I said at the start, just read it again, read it aloud, and take a deep breath if you're like, I don't understand this, and you're like, I'm stressed and stuff, because that happens. And it's like once you get it, you'll be fine. And then if you read it and you just still don't get it, then just move on to the next one. Same usual exam advice. Generics are sometimes challenging, but I would say just like get comfortable with generics, and like I'm not super comfortable with hard stuff with generics, like you just saw. So it is difficult. And you just got to try stuff. I know we say you can't use the internet, but if you need to Google something, that's fine. I'm not fussed about that. Okay, so let's do this domain modeling. We'll go back to here. Again, and like, don't worry about assumptions. Oh, sorry, week 10 lectures. That's a good question. I will chase that one up. They're on Blackboard though. You can watch. Well, there's only one lecture and it's just the guest one. So we have some passengers. They can have flights. They have times. They can be identified. Sure. Each flight has a series of seats. Each flight and passenger schedule includes the class of that seat. Okay, cool. Each flight has a seat allocated to each of its passengers. Okay, yeah, sure, that makes sense. Blah, blah, blah. Okay, let's add flight. So we've got departure, arrival, from, to, the flight name, and a list of seats. Then we can create a booking, we can change the booking, we can cancel the booking. So let's do flight.java. And again, we're just writing the prototypes, the APIs. So we'll probably have a constructor that's like public flight. And that's going to take in from, to, local date, time, what is it? Departure and arrival. Oops. And then what else can we do? Oh, sorry. Airline, here we go. Create booking, change booking, cancel booking. Okay, so let's do, we're going to have a list of, maybe we can have like a map or something. A map of users, or what are we? I guess we can just model passengers as strings. These are going to be like the passenger IDs. And then, no, that's not going to work. Now we'll just have a list of string passengers and a list of string seats. Yes, so you would create the files like I'm doing here, but you won't actually implement any code. So you'll just have like the fields and then the methods. Okay, so create the passengers and seats. What else have we got? I think that's it. So then we'll say public void book, and then you're given a passenger ID and what kind of seat they want. Or, and this is like seats is just going to be, you know, like business, economy, that sort of thing. So this is type of seat. Okay, next one. Blah, 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 create booking, change booking. We want a new flight day. That's all at the control level. That's all at the control level. We can't, maybe we need a booking, and we might return a booking object. Again, some of these abstractions might be benign, but we're just modeling the domain here. So the booking will be for passenger ID, and what do we want? We want private and public, sorry, private flight. And so rather than having passengers, we'll have a list of bookings. And so that you kind of can see that your design will evolve as you kind of just think about it and you go, oh, I'll change this and we'll change this. And this will be a bit of composition, because if you remove the bookings, then, sorry, if you get rid of the flight, then the bookings semantically die as well. Seats, this again will be composition, and one flight can have many bookings and one flight can have many seats. So when you do these, just sort of note down the cardinalities and whether it's an aggregation or composition for these relationships. So it's going to return null. Cool, and then like this one, change and cancel can probably be done at the controller level. like I don't see a whole lot of need for, I guess, stuff in the actual flight itself. Or I guess you probably need a cancel booking actually. Republic void cancel booking. And this is just going to remove it from the list. And this one will call cancel and just book it on a new day. Again, more stuff that can be handled at a high level. Yeah, I think that's it. So this is all you need to do. I think, very simple. It kind of seems complicated because you're like, oh, I have to build the whole thing from scratch. But just think of the surface level behaviors. Again, you can think of it, it's like 3 marks. You kind of need to think about sort of less than 5 key ideas. Like these are sort of designed to make you think in a small scale. If you're spending more than 10 minutes on this question, I would ditch it and come back to it at the end because you want to just not feel like you're pressured for time in the programming questions. This one, if you want to, for this business logic one, watch the last live stream. If you can't do this part, don't worry too much about it. It's kind of, I think it's kind of interesting, but it's a bit, again, it's kind of like hard to, it's just not that great of a question. This one is like level 2, so I would recommend doing that. And that's the exam. So I have 10 minutes left. I still wanted to go through the patterns, but I feel like there isn't time, and people will probably still have more questions. So I'm going to go back to the here is no test about and/or. Sorry, what do you mean by that? For question 13. As in, there was no provided test. His last exam was our last year's exam. What was the average mark? So okay, let's talk about stuff to do with the exam, or this stuff here, where it's like you'll be okay regardless of how it goes. And I know, some people get stressed at any point, whether it's now, the day before, during the exam. The first thing is many of the marks are for design rather than correctness. So if you designed it well, then you'll get marks. The other thing is, if you're finding the exam hard, probably everyone else is finding it hard as well. We're going to do our best to make sure the exam is manageable and achievable for everyone, but it's honestly quite a difficult exam to write. So, maybe we won't get all of it right, maybe we'll get some of it right, whatever. Ultimately, your marks, because of this fact, like, if everyone finds the exam hard, we'll just scale the exam. And we've done that in the past. I won't say what the average mark for last year's exam was because that wasn't the mark that was reflected in the, there's raw exam marks and scaled exam marks, and the scaled ones are what get reflected in your transcript. And sometimes when we mark the exam and you get the raw mark and then we scale everything up and you go from the domain of raw scores to relative scores. And that's just how education works. I know, a lot of you come from like the high school mentality where sort of marks kind of have to semantically equate to something. But at uni, things are a bit kind of more, I guess, I don't know, relative in that sense. So bottom line is, if everyone finds it too hard or if everyone does badly, because sometimes you actually probably did okay, especially to do with how we mark it. But yeah, if everyone does badly, we just scale it. And just generally, a piece of like life advice is focus on yourself and not others. Don't worry about how other people are going. Just focus on where you're at. You've got 3 hours. It's you, your computer, the exam, and that's it. And then it's all done. The course is over. That's it. You can never think about COMP2511 again. So yeah, try not to worry too much. You'll be fine. Will the just defined exam be similar? Again, it's like I said at the start, some problems are easy to understand, hard to solve. That's what we aim for. Some questions are hard to understand, easy to solve. So, and it's different for different people. So I can't say anything sort of definitively about the difficulty. The short answer will be pretty similar. The programming will be hopefully more manageable than people found it in the past, is what I'd say. Okay. The other thing is like surprises. So we're going to tell you sort of roughly what's in the exam so that you kind of can go in sort of knowing what you need to expect. And yeah, just like, you know, someone once told me that the way to deal with students is like if you tell them something's going to happen and then it happens, then they kind of feel like everything's going to be okay. So yeah, sure, I'll just chuck in the repo and put it in with the solutions. So short answer questions, there'll be things like given some code, discuss design principles, given code, identify code smells, we did that today. Given a scenario, identify a suitable design pattern, show the mapping of the domain to the pattern's key characteristics. Explain why blah, blah, blah is good or bad design. This is a lot of stuff and this can apply in a lot of settings. Then we might say, here's an implementation like a UML diagram. We want you to work backwards and tell us what the original design was or how the patterns or something applied. There'll be the domain modeling question. We just talked about that. And then design and programming, going to be 2 questions. This might change slightly. I just say that as a disclaimer in case we do change it, but it'll probably be roughly like this. This is just the question number. Question 13, it's going to be about authorization. So you did authentication for Lab 5. It's separate, but it's just a sort of a related topic, which is to do with permissions. So that's like, again, this is sort of about the real world element that's filtered its way into the exam. You'll need to, like we just did, identify code smells, refactor, handle some new requirements, and you'll be using design patterns as part of that question. Pretty straightforward. If you need practice, like the other thing is we won't ask you to do the sort of refactoring you kind of have to do in Lab 5 where it's very high level and you're sort of moving around classes and stuff because there's just not enough time to deal with that sort of scope. So yeah, don't feel like you're going to be given Lab 5 as a simple question. So that's a refactoring question. Then the last question, basically, if you do Lab 8, you will find this question okay. If you haven't done Lab 8, I imagine that you will struggle with this question just because a lot of the ideas in Lab 8 are, it's essentially sort of Lab 8, but in a different, with a different sort of problem context. So that's the first thing I'll say. The second is the functional paradigm is very central to this question. I'll talk about currying in a second. This is just something that you kind of probably have seen before, but I'm just putting a name to it. The sort of functional style decorator pattern is going to be a big part of this question. Again, this is what sort of Lab 8 is based on. There will be lots of generics, so try and be as comfortable with them as you can. There'll be just things like public T, T return or blah 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 blah. And there'll be T, and there'll be some more like function X T stuff like this. There'll just be lots of type parameters kind of flying around. So try and get familiar with that as you can. This sort of question is very much based around functions as well. This is another point for that. There'll be some stuff to do with iterators, and the other thing you should be familiar with is exceptions or your try-catch, exception handling, that sort of thing. And that's it. I'm going to go through the course outline as well. Just to so basically, like all of this stuff is in the exam because this is what the whole course is based on, right? As the sort of foundation. The OO stuff. This is obviously an exam. Yep, that's an exam. That's an exam. You'll be given JUnit tests to run to check correctness. There'll be absolutely questions about design principles. There'll be refactoring. There'll be functional stuff. These patterns are all fair game. The programming the large stuff is fair game. Event-driven programming, observer pattern, design by contract, composite. This is all in it. Yeah, I was going to talk about like the key characteristics, and these are both like things to look for, and then also how to go about like the mapping to the when you see observer pattern, what are the things you should be writing in that response or thinking about. I would let's go over time actually. Let's bite the bullet. So I'll do this and then we'll do more on design patterns. Yep, this is all in the exam. This is an exam. This is all in the exam. The concurrency stuff and the singleton pattern is we won't give you a question like in Lab 8 where you have to figure out where to put the synchronized. No, I extended it to 6. Yeah, 6 p.m. So we should be fine. Yes, concurrency. Sorry. It'll be just more like the Tute 8 where you have to do something where you have to sort of synchronize and use a singleton pattern for an entire class. Again, code smells, refactoring, all part of that. Iterators, template, visitor, the stuff on event-driven design. There won't be anything like promises or any of that kind of stuff, but more just the idea of the producers and consumers and channels. Adapter is bonus. All this stuff is bonus. The guest lecture is bonus, not assessed, and that's it. All right, so let's take I want to take a short break just to so I can have a drink, and then I'll just go over some stuff about patterns and any other questions that people have. I know there's a couple other ones I haven't answered yet. So see you in a few minutes. All right, let's finish this off. Thanks everyone for staying a bit longer. I'm going to first go back to question 9, and because I remembered how to do the, well, I didn't remember, I looked up how to do this one. So let's just re-familiarize ourselves with the question. We've done the observer pattern like notification. Oh, sorry. There we go. We've done the notification of what have we done? Yeah, we've called the update method, and now we need to actually do something in that update method. We're going to keep the people the same. Sorry, we're going to keep the update method the same, where we just update the members list. But then we're also going to have a list of visited members, and what we'll just say is we're going to return return members dot stream dot filter, and then we're going to say not visited dot contains m. So this means we don't go through the people that we've already seen before, and then we're going to dot sorted, based on the original comparison method, which in this case you actually need to pass that in the constructor. And in fact, we might not even need the iterator now that I think of it. So we'll just pass in the members and then comparator, comparison method. I think I need to compare that on P. Cool, so that's all done. Bit of boilerplate, and we'll need to fix this up as well, but I won't do that. So we'll sort by the comparison method, then dot find first. No, sorry. This returns a string. No, okay, never mind. Dot collect. What's going on? Sometimes it just doesn't VS Code decides just not to work. Comparison method. What is going on? Find first. .get. The method must return boolean. Yep. The method sorted is not applicable for the type argument. That's weird. I'm not sure, Paris, what the problem is there. I'm just going to go back to the controller. Sorry, I looked at how to do this question, and then the implementation sometimes a bit finicky because you've got the like the whole comparator thing. Yeah, so comparator then comparing blah blah blah, and then what we'll just do here is say collect. Okay, sure. We need to sort then filter. That should work. Comparator, person P. Oh, I think I need to compare to person P. There we go. Cannot convert from person P to P. All right, this is making a bit more sense. And then dot get ID. Cool, that's it. All right, back to design patterns. So I'll just go through and kind of give like a rough. This is all off the top of my head. So you start out with strategy. What are the key characteristics? Again, this is like the whole strategy versus template thing, where strategy is like, your strategy for uni is you do your work, you do your labs, and you try to get everything done early. But if the strategy is not working, you can change it. So we can dynamically change strategies at runtime. You can add or remove strategies at will. So in that sense, it's open closed. And there's sometimes maybe some logic, limited logic around changing strategies. The idea is like you could with the the restaurant example where it's like you go from happy hour to discount to normal price, and you can chop and change between any of them as you like. When you start to put more logic around it, where it's like, oh, I can only change to this case in this certain circumstance, whereas this case is this certain circumstance, then it becomes more like a state pattern. Because you can start having kind of conditions and logic around your transitions. So that's the kind of getting us a state pattern where we have states, we have actions which cause transitions, and there's like logic around those actions. Composite, you've got compound nodes, you've got leaf nodes, and you have this kind of tree hierarchy. That's probably the main thing. And the idea is like composite pattern as an implementation is you don't care whether you're talking to a leaf or a compound node. What's the next one? Observer. Observer, you have the thing being observed, which is like your subject, or your consumer. Then you have the thing doing the observing, which is the observer or the producer. This is also called the subscriber or the listener. And then you have some sort of method of notification, which is push or pull. And what else do you have? There's this idea of like a change in state causes the notification. That's observer, and then factory is just generally you want to create other objects and have some logic around that. Or you want to abstract creation in some way. What else do we have? So there's factory patterns, decorator. You want to again add functionality at runtime. Dynamically add functionality. You've got this kind of layering idea where you can either structurally or semantically kind of layer things on top of one another. And then you just kind of generally have this, again, layering or wrapping, I guess. And again, it's like you don't care what kind of thing you're decorating. So it can decorate to an interface rather than an implementation. So it's decorator. Singleton is more just like, that's kind of just what we discussed in the web server one. Template is you have a series of steps. Some steps are abstractly defined. Some are concretely defined, so it's like some parts of the template are sort of done for you, and then other parts you need to fill out concretely. So we mark these methods as abstract in the abstract class if we use an abstract class for it, which most of the time you will, for template pattern. And then these methods are called hook methods. That's template. What else do we have? Visitor, which is kind of what we talked about before, where you want to separate algorithm and implementation. You want to add functionality to an existing system. Maybe that's like a legacy system. And you can kind of build in, again, I kind of use the term hook sparingly. That's like, this is a commonly used term for template pattern. I've just kind of, like semantically you can think about it as you build in these hooks into the system to latch functionality on. And then I think the last one is just iterator, which is where you want to abstract traversal from the container or algorithm, and you want to linearize or access elements in a linear order, but but you don't know how it works under the hood. Cool. They're just like the key things I can think of. If if there's a question about state pattern, you talked about these three things, then you probably, as long as you talked about all the relevant aspects that were given to you in the question, it says, well, here are the states, here are the actions, here are the transitions. If here is some of the logic around those transitions, then that would be fine for full marks. And you'd want to do that in any sort of programming question as just like, here's what I'm thinking about with the decorator pattern, or here's what I'm thinking about with the template pattern. Cool. There was another question. Oh, I need to show you one thing. I just want to go over the idea of, it's called currying, but you can just think of it as just like functions returning functions, or another way to describe it is partial evaluation. If you do like 3161 or 3141, you really get into this, like these very functional ideas, but basically you can have or we'll call this a public function. Public function, which is going to take in an integer and return an integer. Double, or I should say double function. And then all this is going to do is return a lambda, which takes in x, and then just returns x times 2. Now, when I call this, here's the thing. Cannot make a static reference to, no. Oh, I'll just say it's static, sure. When I call this, there's no actual evaluation being done. Sorry, I need to put in X. What is integer signifying light 86? That's a good question. Sorry, I'm just gonna change this. Return X times 2. No, okay. Anonymous. Sorry, what am I doing? I'm just supplier. So a function, so just to answer you guys' question, I would study these as well, the different like types of functional interfaces. So you have a function which takes in a value and returns value, right? It's like a toaster. You put in bread, you get out toast. And these are the two types. This is the type of the value being put in, and this is the type of the value being put out. We're not going to use that though, because we actually want a supplier, which is, you know, like your, I don't know how to describe it. A shop has their supplier of apples, and the supplier just gives them apples, right? There's no, it's not like a function. It's just like a, you know, like an ATM, I guess. You know, push the button and money comes out. So, why is this not working? X times 2. Lambda's expression signature does not match the signature of the functional interface. Don't know what's going on there. Is that better? This should... Sorry. Again, I should have prepared this. I'll put this in the pushed code later, but Lambda's expression does not match the signature of the functional interface method apply. I want to return a function though. Oh, sorry, I haven't put the right value here. There we go. Cool. So what's happening with that? So you notice this when I print it out, is not actually going to evaluate the function, because we've got a function here, this double function, which returns, well, I guess you could call it a supplier. You know, you just think of it as a function or a method, but it doesn't return a value. It just returns another method. Oh, we still have a compilation problem. Yeah, so this is just like a function, you know, blah, blah, you know, here's your reference and your hash code. And we haven't actually evaluated this yet, even though the X has been kind of baked into the value that's returned. Because if we go, well, system.printf.get, which says actually get me the value this function resolves to, it'll say 4 because you're multiplying X by 2. But this isn't actually done until you evaluate the function itself. So this returns the kind of supplier object, and you say, okay, now I want to kind of evaluate or actually sort of unwrap it and see what's going on. So this is again a concept called currying. Don't have to worry about that, but just this idea of you can sort of wrap up a package and then say, okay, now I'm going to actually evaluate it, or now I'm actually going to unwrap it, is a very functional idea, and it's important to know for the question about sort of like decorators and functional stuff. So I'm going to go back to some questions now. The only other comment I have is about setup, and about someone asked a great question to do with Gradle. If you have Gradle version 7, that's fine. I think the official version we endorse is version 5, but you should be fine with 7. Yeah, 5 or anything bigger than that. So Is there any other ways of telling the difference between state strategy? The only way I know is that states are internal. Strategy, there's an outside influence. The main, like, if you can draw a state diagram, then chances are it is probably a state pattern. The other thing, if you can draw a state table where you have like an action, and then in each of your different states, the action means different things and can transition you to other states. Like the video player example from the tutes, like with authorization, it's a classic one where it's like you can do this thing, but you're on different pages, and it will mean different things, like whether you're, I think it was the interact one was that particular method, but it essentially has different effects depending on the implementation and will take you to other states. I've never used Gradle in my labs, but the pipeline, there's no pipeline, so I would recommend getting Gradle set up and doing it locally. I would also just generally, I know it's the end of the course, it's kind of too late, but like get the environment stuff working locally, because then you don't spend all this time waiting for pipelines to pass. You want to like shift your stuff left, where it's like I would rather find out the issue before I push to Git, rather than like 5 minutes later when I've run the pipeline. Okay. Someone asked a question. Project and lab marks. Probably on the weekend. I can't say for sure. We've asked the tutors to get their marking done by Thursday, I think, but the tutor's very busy, and there's a lot there's a lot to mark with the projects, especially design, because we want to do a good job. So, yeah, we'd rather give you better quality assessment and not rush it. So I'd say probably the weekend. Yeah, we talked about that. So for question 13, it gives us JSON, but the test here is no factory. Yeah, I think we just didn't write a test for that one. Oh, actually, no, that's not true. For question 13 in the sample exam, you have to get parts A and B to work to do it. So you do the factory and the composite. One last thing, possible to look at some decorator being removed at runtime. Shoot example adding. Oh, that one's hard, to be honest. Again, I think I said this in my tute, but it's kind of like that example with the dragon and armor and stuff is a bit made up, where it's like in your project you probably just had a list of the inventory and then just iterated through the list to add your buffs or whatever, rather than having this sort of wrapping of stuff. In terms of removing a decorator, it gets kind of difficult because one of the ideas is that you can just add stuff on and then it doesn't matter like how many layers deep you are. Whereas, it's like once you start removing stuff, you have to do all these weird checks. So I honestly couldn't give you, I can't give an example off the top of my head where you here's where we need to implement removal of decorator pattern. And we won't assess that. Could be interesting though. Maybe an exam question next term. Yeah, okay. Can I scroll down to the iterator pattern? Sure. I'll put all these up with the exams, the sample solutions. Yeah, but just generally though, try not to stress too much. Regardless of how it goes, you'll be fine. As I said, we'll scale if we need to. Hopefully it should be manageable, and hopefully it should be quite interesting. And problems where you kind of understand pretty quickly sort of what you need to do, and then you just need to sort of figure out the design and how to use the patterns effectively and all the stuff that we've been spending the last term together talking about. So if there aren't any other questions, I will wrap it up there. Thank you for staying another half an hour. Need to do that. Need to stop sharing screen. Cool. Thanks, Paris. Thanks, Cameron. Thanks, everyone. Good luck. You'll be fine. And as always, post on the forum if you need anything.